This unit is a Big Blue CellPowa 2500. I purchased it, I made the Kickstarter thing back in May of 2022, and it was finally delivered in January of this year, 2023. And what I want to do is kind of go over some of the things that I have found on this unit. It's a 1.843 kilowatt hour lithium iron phosphate batteries inside. To turn it on, you have to hold this button in for about 3 seconds and let it out. And there we have it at 100%. I have it plugged in right now. And on this side we have 6, and these are 20 amp 120 plugs. And how you can tell the 20 amp, see this little indentation right there on the side? That gives you an indication that it's wired for 20 amps. This is the input for AC. I've not tried any other inputs. Let me go on the other side. And by the way, this is a touch screen, and this is how you activate your AC or DC right here. On this side, you have your 2 fans, your cigarette lighter plug, 10 amp, USB, this would be 3, USB 3, USB-Cs, plug-in, these are 5 amps, and right behind this little sticker right here is where you charge it through solar, which I've not tried yet. What we are going to do is see what the capacity, the real usable capacity, because you probably have some that you can't access. So we're going to find out what the usable capacity is of this unit, and we will plug it into a dehumidifier and a watt checker. So 1 second. Okay, what we found out here is that the idle consumption is 1.1 watt. Now I'm going to turn on the dehumidifier and let it run. And we have a timer up here. We'll see how it does. Okay, our dehumidifier is on and the timer is going. So we've got 17 seconds right now, and it's producing about 444 watts. And I thought, since I'm doing a test, I thought I might as well do something that would be useful in our house by dehumidifying our basement. So we'll get back in about 3 hours, I guess, and see how it's done. By the way, the fans have not turned on the inverter. As a side note, I just wanted to point out, I thought I might as well plug this light in while we're doing this. So it's using 500 and almost 60 watts. I have the kilowatt hours being consumed, and the time has been 7:52. Bring this light down just a little bit more. A side note, when we brought this from Arizona, I just want to say some of the uses that we did. I had it on the back seat, and we brought our T-Mobile home internet with us. And so whenever we stopped to charge our car, our ID4, we plugged in the internet, and we were on the internet while we were charging. Made the time go much, much faster. You don't need this big of a unit for that T-Mobile device, but so we used it. It took us 3.5 days to get here, and we used it. I did not charge the unit, and when we got here, it had 68%. So we took it into the hotel, the T-Mobile, not this, the T-Mobile device, and we used the Wi-Fi from that at each of the motels we stopped at along the way, making our internet secure and fast. It was a very nice feature of the T-Mobile home internet. But anyway, as I mentioned, it's going to be a while before this will be done. There's a lot of uses you can use for these solar generators, and that was only one. One of the other things I mentioned that this is a pure sine wave inverter, and as I mentioned, it was $543 it cost me. It's probably more than that now per kilowatt hour. But you know, when I looked at what for example, a Powerwall, a Tesla Powerwall, that was way over $1,000 when you get it installed per kilowatt hour. You could get a Blue Eddy or something like that where you could stack these and get, get your 240 volt, where you can put several of them together and have 240 volts rather than 120. And you could power your house with those, and probably is a lot less money and more portable. And you don't need permits to put them up for your house for emergency backup power. That's another consideration for these solar generators. I know $543 a kilowatt hour is a lot compared to, the lithium iron phosphate batteries that I'm building. Some of the things that I'm doing right now is my goal is to be 80 to 90% off grid. And so I'm converting, as you'll see as I get into the inverters that I'm putting in there. I'm totally taking, there's nothing going to be grid tied here in our house. It's all going to be with the manual transfer switches, which I will show you it's going to take me about a month to do it. I have 23,000 watts of solar, so all that excess is going to, I'm probably not going to be using it, but it's all going to be going into battery storage. My goal is to get between 60 and 100 kilowatt hours of battery storage in our solar building, which I will show you as I get things set up and all the parts I need to convert it to off-grid, and show you the inverters that I'm using and the batteries. They're all going to be LFP batteries. We already had a fire once from lithium ion fire that the BMS did not prevent it. So I've learned my lesson. I am going to be doing just lithium iron phosphate batteries up there. So anyway, as this progresses, I will see what the capacity of this battery is, what the usable capacity, because they're not going to let me use all the 1.8. And so far, the fans have not kicked on the inverter for 466 watts. As another note, I did unplug the light because it was not on the meter. We have 91%. It says that it's going to go for another 3 hours and 54 minutes, or maybe three and a half hours. And right now, just so you know, the consumption is 474 according to this, and according to this, so it's 477. So it's probably consuming about 3 watts. 3 watts off. That's 470. That's pretty close. 477. And again, we've used 0.137 kilowatt hours so far, and about 18 minutes into the test. We're at 10% right now. It says we got 4/10 of an hour left. It's producing 468 watts. So let's go to we've been running 3 hours and 21 minutes. We've used 1.394 kilowatt hours, and I am going to shut it down because my wife says there's a storm coming in tonight here in North Dakota that we could have a power outage, and she wants us fully charged before that happens. So let's extrapolate. If we were to let this run down to 0, we would consume 1.55 kilowatt hours. Now, that's what we could go down to at the rate of discharge we're doing right now. And at that rate, 1.55 kilowatt hours would be 84% efficiency. It might do better if I were to take it all the way down. So now we're at 1.4 kilowatt hours we've used. That's not too bad. And we're still at 10% battery. So I'm going to charge this up, and one of these days we'll do a DC charge and see if we can take it down further than 1.55 kilowatt hours. thank you for watching, and I will catch you up on my other projects down the road. See ya. Bye-bye.